Hello everyone, I'm Dr. James and this is my first time teaching you guys in the MBBS program. So let me introduce myself very briefly. I am a biochemist and I'm specialized in recombinant protein expression and enzyme characterization. So I teach mainly in the BMS degree program, but also a few lectures from Case 5 Diabetes. So back to our topic today. We know that diabetes is a metabolic disorder. So to understand diabetes, we'll first have to understand the basics about metabolism. So you will have about, I think, 5 sessions with me under this case 5 diabetes. And in case you have any question, just feel free to send me an email. So what is metabolism? Let's look at the dictionary to find out the meaning of metabolism. According to the Oxford Dictionary, metabolism is the chemical processes that occur within a living organism in order to maintain life. So it talks about chemical reactions, but to me, this statement is too general as it is written for the layman. I actually prefer the second definition from dictionary.com, which says the following. Metabolism is the sum of the physical and chemical processes in an organism by which its material is being produced. So this is anabolism, maintained, which is equal to homeostasis, and destroyed, which is catabolism, and by which energy is made available, which is ATP production. So this statement has summed up everything very well. So if you were to use a picture to represent metabolism, what do you think that picture will look like? Well, to me, it will look something like this, which is incomprehensibly complicated. Remember, metabolism is the sum of all chemical reactions in our cells. So that includes DNA synthesis and breakdown, RNA synthesis and breakdown, protein, lipid, energy production, you name it. So these reactions are intertwined into a giant network. So we can't help but be amazed by the complexity of life. Now, if you can zoom into these pathways, you can see thousands of chemical reactions going on. What if just one reaction is not performing? Well, you will get a metabolic disease such as diabetes. Remember, problem with one reaction can impair many other functions in the pathway. So, why do you need to study about metabolism as a medical student? That is because metabolism is the foundation of biochemistry, and we have about 10% of our enzymes involved in the metabolic pathways. And as I mentioned earlier, when the pathway is in imbalance, it can lead to a number of metabolic disorders such as diabetes and phenylketonuria and so on. So for you to fully understand diabetes, we must first understand about metabolism. Okay, showing in this picture was a child with diabetes. Take a guess, was it type 1 or type 2 diabetes and why? Well, the answer is type 1 because the kid was very skinny. Type 1 diabetic patient has little or no insulin production, and without insulin, the kid cannot import glucose into the cells from the bloodstream. And as a result, he did not able to make any fats or protein molecules. So how do we treat patients with type 1 diabetes? Well, we give them insulin. So this is the same boy after he was receiving treatment with insulin. So before that, he was dying and close to the point of death. Then he became healthy, regained his strength and appetite with insulin injection. So how long do you think we have to provide him with the insulin? Well, it's for a lifetime. Okay, showing here is a summary of changes in metabolism in different tissues during the fat and the fasting state. So the fat state is also known as the absorptive state. So when you have taken the meal, the food will be digested into their respective building blocks, such as glucose, amino acids, and fatty acids. And that will lead to the increase in the levels of glucose and amino acids in your bloodstream. And your pancreas is going to respond by secreting more insulin by the beta cells, and at the same time, your alpha cell will reduce the production of glucagon, as both insulin and glucagon have opposite effects. So what is the effect of insulin? Well, it stimulates anabolism or the synthesis of macromolecules. For instance, your adipose tissue is going to uptake even more glucose and convert them into triglycerides acylglycerols, which is the storage molecules of lipids. The anabolic effect of insulin is again seen in your liver, where you get the synthesis of a range of different macromolecules like glycogen, fatty acid, and triacylglycerol. How about your muscle? With insulin, you will get the synthesis of both glycogen and protein molecules. But with your brain, it is a different story, as it does not really react to the insulin. So because brain is so densely packed with neurons, they consume a lot of glucose molecule, and the glucose is completely oxidized in your brain to become carbon dioxide and water molecule. So all this reaction will happen during the fat state. During the fasting state, however, you have the reverse reaction. So I'm not going to cover all these elements one by one, but what you need to know is that you're gonna need more glucagon than insulin to boost your glucose level. And under the fasting state, your liver has the ability to produce both glucose and ketone bodies. And to adapt for that low energy environment, both your muscle and your brain have the ability to oxidize both glucose and ketone bodies for energy production.